Let us continue with the minimum spanning tree technique. So in the previous video, I explained the example of the minimum spanning tree. So the minimum spanning tree can be constructed by using Prim's algorithm or Kruskal's algorithm. In the previous video, I explained about how we construct the minimum spanning tree by using Prim's algorithm. Now let us see the Kruskal's algorithm. So actually it is used to find minimum cost spanning tree, and here we uses the greedy approach. So let me take the example. With the help of the example, I'll explain, means along with the algorithm, I'll explain this Kruskal's algorithm. So first let me take the example. So with the parallelly algorithm with example, I'll explain along with algorithm. A, B, C, D, and let's take this is the B, and here let me take this is T. Okay, and here let's take the loop also. Okay, and the values for this is 8, 7, 3, and the loop is 1, 3, 4, 2, 5, 2, 6 and 9. So let's take this as an example. Now coming to the algorithm, first step. So in the algorithm, first step is we have to remove all loops and parallel edges. In Kruskal's algorithm, first you have to remove all loops and parallel edges. So that means it becomes S, A, C, D, B, T, that's it. So A, 7, 8, 3, 4, 6, 3, 2, 2, 5. So here in this case, if suppose a parallel edges we have to choose the least cost and the remaining all has to be removed. Okay, so here the loop I removed and the parallel edge, so this is the parallel edge. Okay, so this is parallel edge to this, but here we have to select only the least cost. Instead of selecting 6, I selected 9 because 6 is the least cost. So you just keep this 6 here and remove this 9. So this is the loop, so I removed the loop and the parallel edges. Now coming to the second step. So in the second step, the algorithm for the second step is we have to arrange all edges. Step 2, arrange all edges in their increasing order of weight. So I had to select, I had to arrange all the edges, whatever the edges. So these are the edges, these are the vertices, and these are the edges. So I had to arrange all edges in their increasing order of weights. So what are the increasing order of weight? So first is 2. So select BD. So the weight is 2. So next increasing order is DT. DT is 2. Okay. And next is AC. AC is 3. AC is 3. Next is CB. CD. CD is having 3. So CD is 3. Next is CB. 4. So after CB, you are having BT. BT is having 5. Again, next is AB. Yeah. AB is having 6. Next is SA. SA is having 7 and SC is having 8. So now I arrange all edges in their increasing order. First I take it 2, next 3, next 4, 5, 6, 7, 8. So all edges. So these are the edges. So I arranged edges in increasing order. So that is the second step in the algorithm. Now coming to the third step. What I have to do in this third step? So in the step 3, I have to add the edge which has least weight edge. I have to add the edge which has least weightage. Means first I have to select the least weight, the starting, I arranged in everything in the increasing order. So the first is the BD. BD is having the least weight as 2. So I have to add the edge which has least weightage. Next least weightage is DT. DT is having 2. So coming to the next cost is, okay, so here the next BD, DT is over. Next cost is 3. So 3 you are having 2 edges. Next cost is 3. So the edges are AC and CD. So anything you can select, AC or CD. So I'm selecting AC. AC, CD, and this is B, and this is T. Okay. So why I didn't take the CD? I just only taken the AC. First I selected BD, least cost, and next is DT, next least cost. So next is CD. I have to select either CD or next edges are AC and CD. So AC, both I have selected, AC and CD. Okay. So the weights are 3, 2. So the cost 3 is over. Now next cost is 4. So this Kruskal's algorithm is mainly based on the edges. So we are calculate the minimum spanning tree based on the edges. So not focusing on the vertex, adjacent vertices of the visited vertex. But here we are focusing on the edges with the cost, increasing the least cost. So next cost in the table is 4. But we observe that adding it will create a circuit in the graph. Why it is creating a circuit in the graph? Suppose if I select the 4. Okay, if I select the 4, so it becomes closed circuit. So that's why I'm not selecting this 4. Just discard it. So the main thing of the minimum spanning tree is closed circuits are not allowed. So this if I take CB, if I take this 4, this becomes the closed circuit. So just discard this 4. So we observe that adding it will create a circuit that is that in the graph. So we ignore it. In the process, we shall ignore or avoid all edges that create a circuit. So whenever it creates a circuit, you just discard it. Discard, because to avoid circuit. So next cost is I have to select the edges. After 4, what is the value? So after 4, that is a 5. So the 5 I have to select. So if I select the 5, so did you observe here? If I select the 5, it becomes a closed circuit. So just ignore this also. Okay. So just ignore this also. Suppose if I select 6. So the next cost of 5, after 5, the next is the, after 5 it is a 6. The next increasing weight is 6. So if I select 6, this becomes closed circuit. So ignore this 6 also. So next edge you have to select is the, so we have to ignore 6 and 5 also. Next cost is 7 and 8. So instead of in 7 and 8, which is having the least weight, that is a 7. So just select the 7. So now circuit becomes like this. So the final is A, S, this contains 7, C, this is 3, D, this is 3, and B, this is 2, and T, this is 2. So this is MST is completed. So this is how you have to calculate the Kruskal's algorithm. So the only difference here, there, and the Kruskal's and the Prince is, so there we are focused on the vertices, and here we focus on the edges. So there you have to, in Prince, you have to select only the adjacent vertices which is having the minimum cost. But here in edges, you have to first arrange all the edges in ascending order, least cost to the highest cost. So first take the least cost and next select the least cost, and observe for everything whether it is forming the closed circuit or not. Okay, if closed circuit is forming, just ignore that cost. So this is the Kruskal's algorithm. Thank you.